Next up is dynamic air cooling. Dynamic air cooling is an environmentally friendly air conditioning and refrigeration technology that uses no synthetic HFC coolants and features no thermal emissions, bringing a breakthrough cooling technology to fight climate change. Their mentor has been Donna Howell, and Pavel Panasic will come and present for DAC. Welcome to the stage, Pavel. Good job. Oh, you look beautiful. That's great. Here's your clicker. All right.
Thank you. All right. Hi, my name is Pavel, and today I would like to talk to you about something really cool. And that is, of course, cooling. Cooling is the key technology of the 21st century. Do you know that the United States use more energy just to cool down buildings than the entire continent of Africa uses on everything? Cooling plays absolutely crucial role in food storage and reduction of food waste. And we waste immense amounts of food across all of the supply chains, starting with fields and ending with customer homes. Industry tries to compensate these losses by generating more food. But we think that actually the best approach is to reduce waste. And cold roll here is the key. However, existing cooling technology has a major negative impact for two reasons. It generates loads of electricity. It needs lots of electricity, still produced by burning fossil fuels. And second, it uses HFC freons, which are 4,000 times more harmful than CO2. As a result, we will cause 27% of global warming by mid-century just because of refrigeration and air conditioning. So, by making ourselves colder today, we make our planet hotter in the future. And that's why Montreal Protocol requires replacement of 85% of all HFC-based devices by 2035. We have created a new breakthrough approach to cooling, which is called dynamic air cooling. It is based on recuperation of thermal energy of the air. To a certain extent, we can compare this technology to a mini tornado inside of a controlled environment, but using it, we can drop air temperature by 150 degrees. We don't use any chemical freons, and we are able to use up to 30% less electricity. To our customers, we are able to offer absolutely new, very versatile and highly efficient technology, which can cool down anything from a truck to a building using no freons, requiring less electricity, with easy installation, and in much safer way overall. So here is an example of usage scenario based on our discovery trip. We met Mike. Mike is a chicken and egg producer from a Rochester area. He needs to replace his old ammonia-based cooling in his storage, and also he needs to increase cooling space for external seasonal demand, for example, during apple harvesting. Right now, as a temporary solution, Mike has a refrigerated trailer at the back of his yard running 24/7 using diesel power generator. And there are thousands more customers solving similar needs. For Mike, we can provide plug-and-play unit which can fit into his existing storage chambers, and it will cool the same space using half of the electricity. And this is how we did it already. For one of our clients, we cooled down a large 40,000 cubic feet chamber where previously an 80 kilowatt units were installed. So we cooled the same space within the same amount of time using 18 kilowatt prototype. Here is another example, the milk industry. Dairy farmers right now have to store more milk because of increased transportation costs. So that milk is not transported every day, but every second or third day. That means increase of storage capacity. That means increase in cooling. That also means increase in electricity bills. Now let's do a quick calculation. One cow produces 25,000 pounds of milk yearly. 1,000 cows will produce 25 million. Just to cool down that milk, it'll take 218 megawatts of electricity, a cost of roughly $17.5 thousand. Now let me show you how we can save some money. We are developing a next-gen cooling unit together with Delaval, a leading globally dairy equipment manufacturer. That unit will be installed into existing infrastructure and will cool the same amount of milk using 50% less electricity. Now, is it a lot? In New York State, there are 625,000 cows. They produce 15 billion pounds of milk. Just in an area of Grow New York, in a 15-mile radius from Geneva, there are 50 farms with 3,500 cows each. Aside from economic benefits, there are ecological benefits. We are able to significantly reduce ecological footprint of air conditioning and refrigeration. Globally, this represents gigatons of CO2. To bring our technology to the market, we have defined 3 go-to-market steps. First, we validate the technology with selected customers, and we already have signed several agreements and plan to sign more in the nearest months. Then we replicate the technology and scale it, also using contractual manufacturing, and then we scale globally, also via licensing. As for competitors, we do have 2 types. First are Freon-based technologies and players, with a technology which honestly didn't change much for the past 100 years, and then innovative non-Freon solutions. But none of these technologies is able to match the performance of the AC in terms of cost of cooling and versatility of application. We are focusing on a cold chain market. This market is growing globally by 14%. Specifically, we are focusing on cold storage and transportation segment, which is worth nearly $94 billion. And we aim to capture our share of that market. We do appreciate the opportunity presented to us by Grow New York program to conduct a business discovery trip. And based on our findings, this is what we can deliver. Out of total number of dairy farms in the state, 400 are located in the area. It is our goal to build and install first units here. These units will be produced with our Grow New York partners for our Grow New York customers. We already identified over 150 potential suppliers in the whole USA. Out of that number, from Grow New York region come 12 potential contractual manufacturers, 20 partners in food storage, 30 refrigerated truck operators, and then 11 HVAC customers. We were also able to identify a potential supply chain for our technology, following the steps of recession development and validation, local prototyping, small-scale production, and finally, large-scale manufacturing. To bring the technology to market, we will need to finish product development, and it will take us from 12 to 24 months. The cost of this process is estimated at $3.25 million. We have already secured 70% of the amount. Grow New York money will be used to finance the remaining part. Also, we will create multiple jobs opportunities. And here are 3 possible scenarios. One thing, which is not included in this slide, is the amount of indirect jobs. However, when we opt for manufacturing of our products in the area, numbers can get very significant. And we should talk not only about the quantity, but also about the quality of the jobs. We speak about engineering, we speak about technical development, we speak about research and development, not just about moving boxes. Our team is absolutely sure that we can do it. We have a wonderful team of 7 engineers, 2 PhDs. We are proud to be supported by top advisors, including NYSERDA EARs. And to summarize, in less than 3 years that our company exists, we were able to patent the technology, to build full-size prototype, and receive traction on the market. Right now, we want to expand our activities in Grow New York area. We already identified supply chain. We already cooperate with renowned partners such as NYSERDA and NextCore. And we raised interest from global players. And probably last thing I'd like to mention. Modern air conditioning and refrigeration, as we know it, was invented here in Syracuse in 1902 by Carrier. But Carrier production left. We at Dynamic Air Cooling are convinced that right here, together, we can make things much cooler. Thank you.